Hi, I'm Katherine Schwab, an assistant managing editor here at Forbes covering technology, and I am here today with Andrew Anagnost, the CEO of Autodesk, best known for AutoCAD design software, but makes software across all sorts of different fields: design, construction, manufacturing. So Andrew, welcome. Thanks for joining me.
Thank you, Catherine. It's good to be here.
So I want to start with Autodesk's AI strategy. Walk me through it. How are you integrating AI into your software across all of these fields?
Yeah. So, essentially, Autodesk makes software for people that design and make things, like you said. It's everything from the bridges you see, the buildings you see around you, the cars that drive over the bridges, the machines that build the cars. Everything's been touched by our software in some way. And what we do is we help people model those designs, those ideas in 3 dimensions and 4 dimensions, actually, time and space and all the things associated with that, and try to understand how these designs perform in the real world. And what we're doing with AI is we're trying to reduce the complexity of doing that. It's very complex for people to create 3D models, 3D visualizations, and simulate the world that we live in, so that you can actually see how a product, a building, a bridge, or something is going to perform in the real world. So we're applying AI to what are industrial grade problems to help people design things quicker, faster, and kind of increase the capacities of these organizations to build things. And that means building infrastructure, products, all sorts of things. We want people to build more things with the resources they have.
Is there an AI project or a specific example you could give me to kind of walk me through what your approach is to speeding up that process?
I think I'll give a simple example, okay? I think it's really helpful to kind of look at things that people understand. When you're dealing with construction, for instance, okay, construction is a massively fragmented industry, all right? Anyone who's even on a small scale, I mean, people who have dealt with construction on a very small scale in their own lives know that even when they have a general contractor, they tend to be dealing with all these different, and nobody seems to have the information that you kind of communicate. The information seems to disappear and evaporate, all right? AI is very good at wrangling information and interpreting that information for the various people that are involved in the process. So, one of our customers, Myron Construction, for example, they use AI, the AI that we produce, to bring the data together and actually get a view of what's going on in the project, what actually happened, who needs to action the next thing, and actually what needs to be fixed and what doesn't need to be fixed. Because sometimes you can get conflicting information from multiple sources in a construction project. So just at a very simple level, that's something I think that everybody can understand, because they've interacted with construction professionals at some point in their life, and they know the data doesn't flow very good. AI helps the data flow and reduces rework and helps people get to kind of the right outcome faster.
What about the process of starting a big design project? How does your software, now with AI integrated, enable those first 10 minutes to go differently for a design project?
That's a really important point. All right. You mentioned AutoCAD, right? AutoCAD was what the company started on, but really we've moved to much more sophisticated products for our customers. Basically what's called 3D modeling products. And these products are designed to help you get the idea in your head into this 3D representation inside a computer. They are incredibly complex to use. And one of the problems we have is what's called the blank slate problem. How do I get started on a model of what I'm trying to think of? So imagine AI being able to take a series of prompts, pictures, or photos and solve the blank slate problem, give you a preliminary representation of what you're thinking, so that you can then start manipulating that model in ways that actually capture more sophisticated interpretations of your design intent. We like people to be in the loop, and what we want to do is create initial ideas for them that then allow them to edit, refine, work, recreate, and go back. So very simple examples of this are helping somebody create an initial design for a product. Okay, say I wanted to create, we actually demoed this at our Autodesk University just last year. I wanted to create an air fryer. And you want to just start with something, and you want to start with a design that represents an envelope. We can give you a preliminary envelope, and we can give you preliminary connection points for various things that go in. And then you go in and you fix it and you manipulate it to where you're going to do it. That can save hours and hours and sometimes days of work. Another thing we can do is we can create designs of preliminary building block with what's called space claiming type analysis, where you can actually create a block model of a building and assess how it's going to interact with the environment around it. And you can capture all that information early on, and you can use AI to give you answers about wind loads, lighting, and all these things that would take a lot of time and sometimes on-site visits to capture and recreate. We can automate all of that. That's just time back in the designer's pocket in order to kind of dig deeper into the problem and get to the right answer, not just an answer.
I think that everyone sees how long it takes for things to be built in the real world. This is a huge problem. We need more housing. We need more buildings. How could AI meaningfully start to truly reduce the time that it takes to build like a skyscraper, for instance, or a big housing project?
Yeah, so you're pointing to exactly the fundamental problem in these industries, okay? And these are all the industries we serve. There's an enormous capacity problem. There's just not enough capacity to build and rebuild everything that needs to be built in the world right now in a way that's affordable, that leverages available working resources, and is sustainable. This is a real challenge. So what our goal is, and what we're trying to do, is reduce the number of people required per project and the time it takes to execute a project. And time definitely translates into cost. It's not the only thing, but time definitely translates into cost, so that more projects can get executed. This is our fundamental goal. So what can we do within an individual project to reduce time, reduce risk, and reduce complexity early on, so that a project that maybe took 50 people takes 20 people? And that just requires us to remove a lot of complexity from the tasks. And like I said earlier, if you can make it quicker to create a model, if you can make it almost instantaneous to coordinate the data between a general contractor, a trade specialist, an architect, an electrical contractor, an engineering contractor, or a manufacturer, if you can automate the communication of that information so people get the right information at the right time, you reduce risk, you reduce time, and you reduce complexity in the project. That's the way we're deploying the AI right now, and that's the goal for the future. Fewer people, fewer resources consumed, shorter time per project, more projects executed. Our problem isn't the number of projects. We've got lots of stuff to do. And every time you hear about one big project like data centers, everybody's building data centers, okay? What has that done? That takes capacity from other projects, infrastructure projects, home building projects. Home building is a whole different type of conversation. You know, we have a huge gap in homes, 4.7 million homes by some estimates, in various places across the country. That requires not only just innovations in execution, but also innovations in digital permitting. So AI can help us shorten the permitting cycle and shorten the inspection cycle, so that what actually takes months to get through and lots of costs can be shrunk significantly. And those are other things that we're focused on as well.
Is it possible for AI to fully design a building or a product at this point? And what's the gap, if there is one?
So first off, let's ask, is that even desirable, right? Do you want AI to fully design a building? I think fundamentally
Great question.
We should fundamentally ask ourselves that question, okay? Our philosophy is no, we do not want that. What we want is a set of competent human beings that understand human interaction paradigms and human requirements to be engaged in the process of building that building. Now, can an AI today, right now, dramatically accelerate the initial concepts of modeling and designing and planning construction for those? No, it cannot. It can do point tasks right now that help the human work faster. Now, we're moving to a world where the human can say, look, and I'll give the skyscraper example because that's another one that's easy to understand. I'm going to build a 100-story skyscraper. All right, it's got to have 40% mixed-use office space. I want the first 2 floors to be entirely retail. I want everything. I want 30 floors to be apartments. I want the apartments to be divided between two bedrooms, and you specify, and it can give you a preliminary layout of a building like that is soulless. All right, but it's a model. It's a model that you can work with and start creating and building a armature around that is more creative, that is more inspirational, and you can cut the time to get to that dramatically, and increase the human's ability to explore lots of new types of ideas for doing that, and also getting it right. Because some of these really creative skyscrapers you see out there have some really creative maintenance problems. And we don't want that. What we want is a creative building that solves the design spec, but is also maintainable in a really powerful way. It's constructible and maintainable. So you want to learn from the mistakes that other people have made, so that really wonderful thing that you look up at and go, wow, is also easy to build. Not just the most expensive thing to build on the planet, but actually you can build it for a lot less, and you can maintain it. You don't make these mistakes that allow you to have things falling off buildings. I mean, we hear these stories all the time. That's where we're going, but we want the human beings to be part of this process, because I think that's how you not only bring the industry forward, but you keep the industry focused on the needs of the people using the building, using the infrastructure, using the product.
I think a lot of people think of AI as ChatGPT, essentially, a chatbot that writes emails for you, or, does writing-based tasks. But we're really talking about things in the physical world. So I'd love to hear your perspective on what the gaps are between what something like ChatGPT can do and what a more physical-based model can do right now. How do you have to think differently about AI to work on physical models and physical problems?
You have to be able to reason in 3 dimensions and in time. Okay. What do large language models do essentially? All right. They scrub the world. They pull in a bunch of information. They can pull in very specific information. But for instance, you can scrub scientific journals on diabetes drugs to the nth degree and get a very sophisticated system that understands everything about diabetes drugs and the interactions and things associated with it. And you can prompt it, and it will give you back information that may be novel in some of the ways. It'll give you things that could also be completely ridiculous, but it can do those things. So it reasons around the language that it collects very effectively. But that's language. It's essentially a flat way of thinking about things. It's language logic. When you look at the built world and the world that we have to build in, it's spatial logic. And AI is still very immature in the world of spatial reasoning and physical reasoning. So we build some of our own custom models. We've built our own large models that understand a building and understand how a building works, and not just that a door is a thing that's there and exists, and somebody does something and has a definition. A door is a thing that people open on it and it has hinges. No, it's more, how does a door impact a building? How does the cascade of putting a door in position X impact the entire building in some place off in the Z dimension, somewhere completely different? So spatial reasoning and the effect of time and physical forces and analyzing physical forces on things. This is a very immature area in the world of AI. And like I said, we built some of our own models. We're actively involved with people that, like Fei Li, who has a company called World Labs that's building spatially reasoning models. We need these kind of models to advance AI in the built world. We build our own, and we partner with people building those. Large language models aren't going to get you there.
What do you need to get there? So you said this is a very premature kind of space within AI. Why is that?
Because, well, there's a couple of things. One, the data that feeds this kind of spatial reasoning it's not something you can just get by scrubbing the World Wide Web. All right, you'll get a lot of written specifications and things, but spatial reasoning, the ability to actually, like, I'm sitting in front of a TV screen right now. My brain immediately knows that it's about 2 feet away from me. Okay, There's not an AI on the planet that reasons that way right now without bouncing a sensor off of things and doing things. It's not generative reasoning, it's measurement reasoning, okay? It measures the world. We have incredibly gifted skills of spatially reasoning and understanding the world around us that have evolved over, millennia. Um, that's a hard problem to solve, and it requires data that actually represents spatial problems and interaction problems. So, for instance, we train a lot of the productivity features that we have on the data we've collected that allow people to build models quickly. Now, we allow people to opt out or opt in. If we're doing really sophisticated generative stuff, people have to opt in. If they don't like the fact that we're using our data, they can opt out. But for things that make it easier to build a 3D model, we just train on everything. And that means what we're training on this knowledge about how things relate to each other in a product or building in 3 dimensions. And that just isn't what large language models do. They reason semantically, grammatically, not spatially. And yes, it's a more complex problem because of this notion of judging distances and judging things and actually learning from the physical world. It's exciting. It's a great, when the more we can do here, the more unlock there is of this capacity challenge. So it's a very exciting area of work for us, and it's also a very exciting area of research for us to collaborate with.
Do you need a different architecture underlying these models to be able to do this kind of reasoning, or do you think that the current kind of architecture is based on the transformer, which is the T in GPT? Is that going to get us there? And I guess also, what do you see as the thing that's going to make these models truly intelligent and kind of crossing over where they're just as useful for the task that you're talking about as ChatGPT is for writing emails?
So transformers are useful. All right, we can use them, and we can use them with spatial data as well, but they're not going to be the end all be all of spatial reasoning. We need new types of algorithms, new types of innovations. Transformers are very good for this token-based kind of analysis of semantical systems. Built systems can be similar. You can create data graphs that are similar and train in similar ways, but if we want to get to really deep reasoning, you have to move beyond some of the traditional methods. And if, I look, I don't want to speculate on the rise of general artificial intelligence. I think it's generally accepted out there, Catherine, though, that large language models and the current transformer technologies are not going to get us there. Okay, they generate by reference and by probabilistic things, but they do not even though some of these models are called reasoning models, they don't reason in the way that a human being would in terms of applying knowledge to something. To do that, you're going to need visual perceptive things that learn from the world by interacting with it. This is the big key. You'll know when we're starting to crack the world of general intelligence when you see a model that actually teaches itself about the world, rather than being fed tons of stuff and trained over and over on it through a brute. These methods are very brute force, these adversarial training methods. They're incredible. Why do you think they're so expensive? They're incredibly brute force. But what if you have a model that actually you set forth into the world and it learns about the world by doing and experiencing the way a child does? We don't have that yet. So we need breakthrough technologies to get there. I'm not going to tell you what that breakthrough technology is. I have no idea. But I know that the current stack is not adequate to get us there, and we're not on the path right now.
2025 was really about all of these massive computing deals, the data center boom, all of this kind of being committed and projected out over the next couple of years, the energy crunch that's going to come with that, and all of this fear around if this is a bubble. How do you see those big picture narratives evolving in 2026?
So I am a big believer in the slow, steady, relentless progress of technology, right? Yes, technology moves forward in discontinuous leaps at times, okay? The challenge, though, with discontinuous leaps is they're almost always hyped, well beyond their capability, all right? And this is a problem as old as technology has been. And I think what you're going to see is large language models and all things associated with it have real utility today. All right. Like I said, these data wrangling problems, some of these things, real utility to help do these things. What we're doing right now is we're moving into the phase where people are actually applying that utility to specific problems. That's why what we do, vertical AI, industrial AI and things like that, we're trying to apply these things to very specific problems. That's where you start to get meaningful adoption on real problems and not just a bunch of fake videos on Instagram, all right? And which is kind of the dominant understandable paradigm right now for some of these things. But we are delivering carefully crafted, targeted innovations on top of existing technologies and novel technologies we build ourselves. And this is the long, boring work of making a technology useful, is finding the problems and building it out. So while the bubble builds around us and goes around us and hype and things, we just keep steadily going. And we're just going to keep steadily building this work. We've been doing it for 10 years. We're going to keep doing it for another 10 years. I can't tell you exactly, if this external environment is a real bubble or not. It feels like a classic tech bubble. But again, what happens on the other side of these things? Remember what happened on the .com era, where we built out all this infrastructure, and then, we had cats.com, pets.com, we had dogs.com, we had everything, okay? And then all of that stuff really had no utility. It had no long-term utility. And all of a sudden it all collapsed and this infrastructure was left there with nothing to do with it. But what happened? The good ideas, the careful ideas filled up and used and consumed the capacity. It's highly likely we're going to see the exact same cycle with what we're seeing right now. I am very, very optimistic the capacity will ultimately get consumed to solve important real world problems, but there might be some turbulence on the way.
Speaking of turbulence, for young people who are interested in design, who are interested in getting into these fields that you touch, what are the skills you think they should be learning right now that AI will not be able to do in 5 years or in 10 years?
Yeah, so look, there's a couple of things that I think is really important. By the way, we're actively involved with schools to help them understand this. All right, we give all our software free away to educational institutions and students. We don't charge a dime for it, and there's a reason for that. And one of the base skills is interdisciplinary skills. All right, you have to be able to understand the system. Like, look at software development, for instance. Okay, software, it's totally clear that software development is going to get completely turned upside down by what AI can do. So what does the computer science major of the future look like in some respects? And this is my opinion, all right? But I think it's a well laid out opinion. They're going to be more systems level views. You're going to have the deep technology people, and there's going to be a few of those that go very deep into algorithmic methods. And then you're going to have these people that understand the systems. They understand human computer interaction. They understand how a user interface works. They understand how the code works, but they also understand how the tools work to develop the code. So this knowledge of how a human uses the technology and the work paradigm they need in the workflow is going to become a universal core skill. There's actually 3 roles that do that today in a software company. Imagine those roles collapsing to one person, but that one person can be multiplied 20 times for 20 different capabilities. So systems level thinking, interdisciplinary thinking, and critical thinking and human factors are going to be huge assets. This is why, when I look at the world of architecture, for instance, I think architects, believe it or not, after some turbulence, are going to adapt to this in amazingly powerful ways because they are trained as systems thinkers. Architects are trained in human factors. They're trained in space. They're actually trained in what it takes to build something in permitting. They actually think about the whole system. Now, are architects' jobs going to change in the future? Absolutely. Are industrial designer jobs going to change in the future? Absolutely. But those that understand how the system works are going to thrive because I think there's going to be a premium on understanding how all these things come together and helping that AI partner you're working with bring it all together in a way that works for people. And that may sound like a very optimistic view, but I think you have to design for what you want. And what we want is that.
Andrew, thank you so much for joining me.
It's a pleasure. Thank you so much for having me.